Hello everyone. Imagine you're lifting a stone in air, it feels heavy. Now dip the same stone in water and suddenly it feels much lighter. Why does this happen? To be sure that this isn't just an illusion, scientists designed experiments to test Archimedes' principle. This principle says that the upward force, or upthrust, on a body immersed in a fluid is equal to the weight of the displaced fluid. Let's now see how experiments actually prove this with measurements. In the first experiment, we take two cylinders of equal volume, one solid and one hollow. Both are suspended from one arm of a physical balance and weights are placed on the other arm to balance it. Now, when the solid cylinder is gently immersed in a beaker of water, it seems to lose some weight. The left arm of the balance rises because the cylinder experiences upthrust. So what do we notice? When cylinder A is immersed, it becomes lighter due to the upward buoyant force. But here comes the clever part. When we pour water into the hollow cylinder B, the balance is restored. Why? Because the weight of the water added to cylinder B is exactly equal to the buoyant force acting on the immersed cylinder A. This proves that upthrust is equal to the weight of displaced water. The second experiment uses a Eureka can. First, we weigh a solid object in air using a spring balance. Then we fill the Eureka can with water right up to the spout and place a measuring cylinder under it. When the solid is immersed, water flows out through the spout into the measuring cylinder. The collected water is exactly the displaced volume of the solid. Now let's look at the numbers. Suppose the solid weighs 300 gram force in air, but only 200 gram force when fully immersed in water. The loss in weight is 100 gram force. At the same time, the measuring cylinder collects exactly 100 cubic centimeters of water, which weighs 100 gram force. The match is perfect. The loss in weight equals the weight of displaced water. Let's solve this numerically. Given a solid of volume 100 cubic centimeters is immersed in water. Step 1. The weight of displaced water is volume into density, which is 100 times 1 gram per cubic centimeter, equal to 100 grams or 100 gram force. Step 2. If the solid weighs 300 gram force in air, its apparent weight in water will be 200 gram force. Step 3. Loss in weight is 300 minus 200 equal to 100 gram force. This exactly matches the weight of displaced water. The calculation verifies Archimedes' principle beyond doubt. So to sum up, both the cylinder balance method and the Eureka can method confirm Archimedes' principle. In every case, the upthrust acting on a body immersed in fluid is equal to the weight of the displaced fluid. This experimental proof gives us confidence that the principle is not just a theory but a measurable law of nature. I hope you now understand how experiments make Archimedes' principle rock solid in physics. See you in the next session with another fascinating idea about flotation and buoyancy.